Today, we are going to dive into a framework that can totally change how you look at, well, pretty much any system, from a huge factory to your team's software project. It's called the theory of constraints, and the core idea is deceptively simple. Find your single biggest problem, focus all your energy there, and watch everything else start to fall into place. But let's start with a feeling I bet you know all too well. You look around, and your team is flat out. Everyone is busy. I mean, really busy. People are hitting their individual targets, machines are humming, keyboards are clacking, but for some reason, the whole project just feels stuck. You're not actually getting more done. So what gives? Well, the theory of constraints has a surprisingly clear answer to that exact problem. And the solution, believe it or not, lies in a really simple but powerful analogy. It's an idea you already know, the concept of the weakest link. Okay, so I want you to picture your entire process, your whole workflow, as a big, heavy chain. Each link is a step, or maybe a person, or a piece of equipment. Now, if you wanted to make that chain stronger so it could lift more weight, would you go and spend a ton of time and money reinforcing the strongest links? Of course not. That would be a complete waste because no matter what you do, that chain is always going to break at its weakest point. Improving any link other than the weakest one does absolutely nothing for the strength of the system as a whole. And that right there is the heart of the theory of constraints, or TOC for short. It was developed by a physicist, Dr. Eliyahu Goldratt, who had this big insight. He realized that any complex system, whether it's a factory or not, is held back by just a very small number of limitations, or constraints. He saw that a factory's total output isn't decided by its average performance, but by its single slowest part. You know, the bottleneck. Now, to really use TOC, you have to kind of flip your thinking. See, most places operate in what Goldratt called the cost world. The focus is on local efficiency, making sure every person and every machine is always busy, to get their money's worth. But TOC pulls us into the throughput world, where the only thing that matters is the final output of the entire system. Think about it. Why run a machine at full speed just to create a giant pile of parts that the next machine, the bottleneck, can't even handle yet? In the throughput world, it's actually better for that first machine to sit idle than it is to create a bunch of waste and clutter. It feels weird, I know, but it's an incredibly powerful shift in perspective. So, you're probably asking, okay, I get the big idea, but how do I actually do this? Well, the good news is there's a really clear, actionable toolkit. It's a cycle called the 5 focusing steps, and it's designed to systematically improve the entire system, not just patch up one little part of it. All right, here's how the playbook works. Step 1, identify. You've got to find that one single weakest link in your chain. Step 2, exploit. This means you squeeze every last drop of performance out of that constraint without spending a bunch of money. Can you tweak its schedule, fix some bugs, give it better inputs? Then, step 3, subordinate. And this one is absolutely crucial. Every other part of the system now exists only to serve the constraint. Everything is secondary. If your bottle needs a 5-minute break, the entire line stops. You don't let the other parts keep producing stuff that just piles up. Step 4 is elevate. Okay, if you've done all that and you still need more, now you invest. Buy the new machine, hire more people for that one specific role. And finally, step 5, repeat. Because as soon as you fix that weakest link, guess what? A new constraint is going to pop up somewhere else. So you go right back to step 1 and start the whole process over again. It's a continuous loop of improvement. To really get what makes the theory of constraints so different, it really helps to compare it to another very famous improvement method. This comparison makes its laser-focused approach super clear. So let's put TOC up against something like the Toyota production system. Now, the Toyota system is brilliant, and it's all about eliminating waste everywhere in the process. It empowers workers all across the board to make continuous improvements. It's a broad approach. TOC, on the other hand, is ruthlessly focused. It zooms in on the process and that single biggest constraint. The goal isn't just to eliminate waste in general, it's to maximize throughput, which is just a fancy way of saying the rate at which the system makes money. It's a single-minded focus on the one thing that's holding you back right now. So, what happens when you get this right? Well, the results can be absolutely transformative. But like any really powerful tool, it comes with a couple of critical warnings you need to pay attention to. When you actually implement this correctly, the efficiency of your whole system can just skyrocket. You get this much smoother process flow because you're no longer creating these massive piles of inventory in front of your bottleneck, and that translates directly into reducing costs, improving quality, and making your delivery times way more predictable. That gives you a serious leg up on the competition.
And this is a huge but, the entire framework hinges on one thing. You have to correctly identify the constraint. If you fix the wrong problem, if you make your entire system subordinate to a link that isn't actually the weakest one, you won't just waste your time and effort. You can actually make the whole system perform even worse. So the most important thing is to be absolutely sure you've found the real bottleneck before you start changing things.
So let's wrap this up. What's the key takeaway here? The real power of this theory isn't just for a factory floor. It's a mental model, a new way of thinking that you can apply to any project, any team, or heck, even your own personal productivity. You know, Dr. Goldratt himself summed up the whole philosophy perfectly with this quote. It's not about making individual parts or individual people look good. It's not about optimizing one little piece of the puzzle. It's always about the performance of the system as a whole.
So I'll leave you with this final thought. The theory of constraints isn't some one-time fix. It is a continuous, never-ending loop of improvement. The second you solve one bottleneck, another link in the chain becomes the new limiting factor. And that's the real challenge, isn't it? It's not just about finding your weakest link. The real question is, once you've fixed it, can you find the next one?